This we conclude we have a pulse train of t period with magnitude a. Fourier series for that is a by 2 plus 2a upon pi cos omega naught t minus 1 by 3 cos 3 omega naught t plus 1 by 5 cos 5 omega naught t, and so on. With this Fourier series, we can develop another Fourier series with small changes. This idea is very important. This Fourier series, pulse train Fourier series, again used in communication, and in exam it is directly used. So better to learn this expression regarding this. And remaining rectangular pulse are derivative of this Fourier series. How it is possible? Let's see. We can use a different idea just by taking double of this waveform by multiplying 2 with this waveform minus t by 4 to t by 4 t 2a by doubling this pattern t by 2 and t location. By doubling we got Fourier series fs is into 2 plus 4a upon pi cos omega naught t minus 1 by 3 cos 3 omega naught t plus 1 by 5 cos 5 omega naught t, and so on. Now we reduce the DC level from this expression. Now this pulse train is converted into square wave pulse. From pulse train we develop square wave with magnitude oscillate between plus a to minus a. Square wave Fourier series have Fourier component 4a upon pi cos omega naught t minus 1 by 3 cos 3 omega naught t plus 1 by 5 cos 5 omega naught t, and so on. This is the derivative of previous expression, pulse train. Now we change one more change in this waveform and we can develop another Fourier series. We just shift this pattern by t by 4 amount. T by 4 means a periodic pattern. T by 4 shifting means what is mean by, if t duration shifting means 2 pi is equivalent to 2 pi rotation, t by 4 means it is equivalent to 2 pi by 4 means pi by 2. If we shift delayed this expression by pi by 2, result will be newly Fourier series. First I draw new Fourier series and then write down expression for this. Expression is now 4a upon pi cos omega naught t minus pi by 2 minus 1 by 3 cos omega naught minus pi by 2 plus cos 5 omega naught t minus pi by 2 and higher terms. We are not considering further higher terms. Now this expression start from 0. This expression is reduced to 4a upon pi cos minus theta cos minus 90 theta minus 90 degree. In this quadrant cos is positive but it converted into sine. Again next term cos 3 omega naught t minus 3 pi by 2. In this quadrant 3 pi by 2 pi by 2 into 3 means 3 pi by 2. In this quadrant cos is negative, so 1 by 3 sine 3 omega naught t plus 1 by 5 pi by 2, one more pi by 2 from this location. Again cos is positive, sine 5 omega naught t and so on. So now this waveform, by shifting we calculate the sine term, odd harmonics of sine terms. So directly we can conclude a Fourier series can be developed from basic Fourier series pulse train. Square wave, by shifting we can develop another Fourier series. It is an example of just shifting. One more important Fourier series for gate aspect, because in gate they are directly ask the trigonometric Fourier series we have to learn. We can put the formula but formula takes some time, so we have to learn. If we learn the 2 and 3 basic Fourier series, remaining are derivative of Fourier series. One more example, a triangular wave form. I draw a triangular waveform and its Fourier series is diagonally write down, which to be learned for future reference. A minus a, this location is t by 4, t by 2, 3t by 2 and t, minus t by 4, minus t by 2 and so on and so on. This is a triangular Fourier series. Fourier expansion for this is 8 a upon pi square cos omega naught t plus 1 by 3 square cos 3 omega naught t plus 1 by 5 square cos 5 omega naught t plus 1 by 7 square cos 7 omega naught t and so on. By shifting this waveform we can develop another waveform, Fourier series waveform. Let's example I draw a waveform which has some symmetry also, is 2 4 2 4 6 minus 2 minus 4 and so on. We want to calculate Fourier series for this by comparing previous triangular waveform. How it is come? This waveform have some DC value. We can calculate DC value. Period for this waveform is 4. We can calculate DC value. DC value come from area covered by ft dt 1 upon t for duration t. ft dt for a duration means area covered by this pattern 1 upon t. T is known to us. Area covered by this is half into base into height plus half into base into height. It's come around 4. 4 divided by 4. DC value is 1. DC value is 1. The area upon total time period is 1. Area covered by periodic waveform in a period upon t. We calculate the DC value. If we draw this line here, we came to know it is similar to cos pattern, negative cos pattern. It's similar to negative cos pattern. I draw cos parallel to this. Cos parallel to this means at 0 location minus 1 value means it is minus cos. All the term in term of cos with negative sign. We directly write down expression for this is 1 minus one minus 8a upon pi square cos omega naught t plus 1 by 3 cos 3 omega naught t square 1 by 5 square cos 5 omega naught t and so on. For higher term we are not considering. Fourier series directly we can write. Fourier series now is a. Value of a is here 1 because triangular wave is oscillate between 1 and minus 1. 1 here. 8 upon pi square cos value of omega naught is 2 pi upon capital T. Omega naught is 2 pi upon 4. Omega naught is pi by 2. Cos pi by 2 t plus 1 by 9 cos 3 pi by 2 t plus 1 by 25 cos 5 pi by 2t and so on. This is the Fourier series expansion for this waveform. We can calculate the Fourier series expansion for any waveform via formula. If there is any symmetry with triangular waveform, rectangular waveform, any other waveform, we can derive in this way. Next, move to exponential Fourier series. Exponential Fourier series. For exponential Fourier series, ft is represented by exponential Fourier series formula is summation minus infinite to infinite cn e power j n omega naught t, where cn is exponential Fourier series exponential Fourier series coefficient. This coefficient come out from 1 upon t 0 to t ft e power minus j n omega naught t dt. With this formula, we can calculate the exponential Fourier series coefficient. With the exponential Fourier series, we can get two terms. Spectrum obtained is two-sided spectrum. Spectrum obtained is two-sided spectrum, and second one is negative as well as positive frequencies denote opposite phase angle. For example, we can use again pulse train for exponential Fourier series. T by 2 4, t by 4 minus t by 2 a t, we can use this waveform function value putting into the formula. What is the function value? As previous, a is defined for t by 4 to t by 4 minus otherwise 0. By putting this value, Cn equals to 1 upon t minus 4 by t by 4 to a e power minus j n omega naught t dt. By solving this, we can calculate value of Cn, and by putting value of Cn in this formula, we can get exponential Fourier series minus infinite to infinite Cn positive n omega naught t.